So in this video we are starting chapter 4, that is moving charges and magnetism. So basically in this chapter we are discussing that how magnetic effect is related to the flow of current. So first of all we will discuss about Orsted's experiment. So here what happened is you can see in the introduction that in 1920 a scientist, that is Christian Oersted, demonstrated that both electricity and magnetisms are uh, intimately related. That means where there is current there is magnetic field, or in reverse way you can say where there is a change in magnetic field we get current. That one, this part we will discuss in next chapter in electromagnetic induction, but in this chapter we are discussing that when there is a current around the loop or around the wire or around the conductor we get some magnetic field. Okay, so first of all Oersted's experiment, what he did in his experiment. Simple experiment. See here there is a see that there is a battery. With this battery there is a variable resistance. How will you understand that this is a variable resistance? You see this arrow represents that it is a variable resistance. Okay, now there is a key, and then a magnet is this is a magnetic needle. A magnetic needle is kept near this circuit. Okay, now what happened is it is seen that when current flows in this direction, because see this is the positive of the battery, so from this part, no, so from this positive current will come out like this, it will flow in this direction. So when current is flowing in this direction, it is seen that this magnetic needle, initially when no current was in the circuit, it was like this, in this direction, in north south direction it was lying. But as soon as the current in the circuit starts flowing, this magnetic needle shows deflection. See, it goes this side, and this side it comes like this. So it deflects. Now the question is that a magnetic needle is nothing but it is made of magnet. So a magnet can deflect only when it is kept in a magnetic field. That means you have seen many times that if one magnet is there, if you bring another magnet near it, then either there will be attraction or repulsion. Okay, and as a result the magnets will deflect. So that means one magnet can undergo deflection if and only if there is a magnetic field near it. That means this current which is flowing through the conductor, it is creating a magnetic field around this region, and due to this magnetic field this needle is deflecting. The same experiment, same kind of experiment he has performed like this, just changing the polarity of the battery. That means initially positive was this side, now negative is this side, and he saw that current is flowing in opposite direction obviously, and at the same time the needle also shows deflection in opposite direction. See, in this case this side it was going like this, no, but here this side is going this way. So though the deflection is there, it is in opposite direction. That means with the change in the direction of current, the direction of magnetic field has also changed. These are the inferences or conclusions made by Oersted. So what he has written here, number one, when current was allowed to pass through a wire AB, this is AB wire, okay, placed along the axis of magnetic needle, kept directly below and close to the wire. Okay, the magnetic needle is kept below the wire. Fine. The needle was found to deflect from its normal position as shown in figure. Okay, that one already I told you. Next, the deflection of the needle was found to be in the opposite direction on reversing the direction of current by reversing the polarity of the battery, this case. Number 3, deflection of magnetic needle changed with the strength of electric current. Okay, another thing what he did in number 3 point, what is written, Suppose if you increase the current in the circuit or in this circuit, then the deflection, the amount of deflection becomes, it increases. That means this magnet, it goes more this side. Okay, so intensity of magnetic field is directly proportional to the intensity of current. More the current in the circuit, more is the magnetic field intensity around it. Okay, so these are the three observation that is made by Oersted, and what he concluded here, these observations led Oersted to interpret that there must be some magnetic effect around the wire carrying electric current which deflect the magnetic needle. Okay, he concluded that an electric current, that is the flow of electric charge, electric current means nothing but is the flow of electric charge, in a conductor produces magnetic effect in the space around the conductor. In other words, flow of electric current is the source of magnetic field. This is the conclusion given by Oersted. Okay, but in Oersted's experiment, in which direction the needle will go, or north end of the needle will go in which side, this is not specified. This was not specified. Who did this one? Next, Ampere, by his swimming rule. There is a rule, we call it Ampere's swimming rule. So with the help of Ampere's swimming rule, we can say that the magnetic needle will deflect in which direction. Remember that since magnetic needle generally it is used to detect the direction, because magnetic needle, when it is freely suspended or kept freely, it always remain in north-south direction. One end of the magnetic needle always faces north, one end always faces south. So that is why we say that magnetic needle, it has two poles. Not only magnetic needle, all the magnets actually, it has two poles, north pole and south pole. Okay, now Ampere's swimming rule. Suppose it is given that direction of the deflection of magnetic needle due to electric current can be found by applying this rule. Says that imagine a man who swims along the conductor in the direction of current facing the needle, such that current enters his feet, then north of the needle will deflect towards his left hand. North towards left hand, that's what is he said. Means, suppose if this is a wire, this one, conductor through which current is flowing. So we will imagine a person who is swimming, and the face of the person is facing the wire, that means towards down. Okay, or facing the wire, or you can say facing the needle, because the needle is kept down below the wire. Okay, so the person's face is facing the needle. It is given the current facing the needle. So we will imagine that the current in the person's body is entering through his feet from this side. Okay, and leaving through the head. Okay, fine. Now if this is the direction of current, then according to this rule, the north pole of the magnet will deflect towards left hand side of the person. If this is the head of the person, the left hand side is this side. This side is left hand side. So this north pole will shift this way, and as a result the south pole will shift this way. So the needle will deflect. Initially this was the north side, north pole, then the north pole goes this side and the south pole come like this. Can you follow that? Now suppose, okay, this one you will understand. Suppose now the current is in opposite direction. The current is like this. Then we will imagine the person's person's head will be this side and the feet will be this side. Okay, you imagine that condition. Current is reversed. In that case, since this will be the head of the person, this side will be the legs of the person. Current is entering through the leg and leaving through head. So north side will deflect towards left. If this is the head of the person, left side for the person is this side. So north will deflect towards left. That means this north will go this side and this south will go this side. So the direction of deflection of the needle will change as the current in the wire has changed its direction. In this way we can detect in which direction the needle will deflect. Now suppose another case. Now suppose this needle is okay. This needle is not here, but the needle is above the wire. Means suppose this is the needle. Okay, this is north side. This is south. Now the current in the wire is same only like this. So if it is so, for this person, left side is this side, no? And right is this side. So north pole will deflect towards left. So if north pole deflects towards left, this north pole will go this side. Okay, another thing, very important thing. See, it is mentioned that the person's face will face the needle. That means this time there is a difference. The person's face will be upward because the person has to face the needle. The orientation will remain same. I mean the legs will be this side, head will be that side, not a problem. But the face will be upward, facing the sky. Okay. So if it is so, then which one will be the left side for the person? If the person faces the sky, the left side will be this side and the right side will be this side, and north pole will shift towards left. It is written, right? Yes, this one, towards left hand. So that means if this side is left, then this north pole will shift this side and south will shift that side. Clear? Okay, so you cannot keep the person in this way. You have to imagine that the person is facing the needle, that means facing the sky, and in that case this is left side, this is right side. So north pole towards the left, south pole towards right. So I hope it is clear. If you have any doubt, you can ask. Okay, you can ask, then I will explain again. So I think this much is clear. In next video we will discuss about magnetic fields, its unit and its dimensional formula.